Hi friends, to have a better understanding, let's take one more problem on Banker's algorithm. That's under the deadlock avoidance. Just verify whether the allotment of the resources will keep the condition under safe state or not. Just that's what we need to check up, and that is what we do in the Banker's algorithm. So let's take up another example where now we have four types of resources, and there are multiple instances of these resources. Like A has got 3 instances, B has 14, C has 12, and D has 12 instances respectively. And we have 5 processes, P0 through P4, and at any given instant these are the allotted instances. So P0 has got 0, 0, 1, 2 instances of A, B, C, D respectively, and the maximum requirement is 0, 0, 1, 2 itself. So that means whatever it wanted, it's already given to it. So these are the various allotted things, and these are the maximum requirements, and looking at this we can identify from how many are totally available and what is already allotted. Now we can see that there are totally 1520 instances of A, B, C and D respectively are available for usage, and the difference between the maximum need and allotted will be the current need. So process P0 has got all whatever it wanted, so nothing is required. Process P1 requires 7, 5 of B and C respectively, and P2 requires 1 and 2 instances of A and D respectively, and so on. So that's the current scenario, and let us see, will this be able to complete all the 5 tasks? If so, then what order, and so on. So let's jump into it. So I just copied that in the same table, just reduce the size of the table, but the matter is the same. So let's begin. So to start with, we have 1520 instances of A, B, C and D respectively available, and let us check what P0 requires. P0 requires nothing, therefore we can take up P0. So complete the process P0, and once the P0 process is done, then 1 instance of C and 2 instances of D are now released. So now the available will increase to 1 more in C and 2 more in D, so that makes 1532 from 1520. So that is current availability. Now let's check, can we continue with next one, that is P1. P1 requires 1750. So 1 for A is okay, but for B it requires 7, so 2 deficiency, therefore we cannot take up P1 at this instant. So let us keep P1 pending and proceed further. So availability as it is, nothing changes, 1532. Now let us check for P2. What P2 requires is 1002. P2 requirement is 1002, and 1 unit of A is available, 2 units of D is available. So we can take up this job and allot 1002 to P2 from this available resources, and therefore P2 can start its work because it has got all the required resources, so it can complete its process, and then it will release 1354 units of A, B, C and D respectively, because they were held up by P2 before its execution. So this gets released. So after P2 completes, so 1354 gets released, 1 gets added to A, so it becomes 2, 3 added to B, 5 plus 3 8, and 5 added to C, 3 plus 5 is 8, and 4 is added to D, 2 plus 4 is 6. So now we have 2, 8, 8, 6 resources available of A, B, C and D respectively. Now let's check, can we proceed with D? So what P3, sorry, can we proceed with P3? So what P3 requires? It requires 2 instances of resource C. So we have 8 instances of resource C, so there won't be any problem in allotting 2 instances of resource C. Therefore we allot it, and once these 2 units are available to P3, now P3 has got all its requirements, and therefore it continues execution, and once it completes its execution, then the resources it was holding, that is 632 of B, C and D respectively, will be released, and after that what is available, so nothing of A released, so 2 remains 2, 6 instances of B released, so 8 plus 6 14, 3 instances of C released, 8 plus 3 11, and 2 instances of D is released, 6 plus 2 8. So that's current availability, and let us check, can we proceed with P4? What P4 requires? 0642, so 6 yes available, 4 yes available, 2 yes available, therefore we can continue with P4 by allotting 6 instances of B, 4 instances of C and 2 instances of D, and once these are allocated, then all the required resources are now with P4, therefore P4 can comfortably continue its execution and complete its work, and once its work is done, it will release the resources it was holding. What it was holding? 1 instance of C and 4 instances of D. So once that is released, then what we have is 1 instance of C, that makes 12, 4 instance of D, that makes 12. So now we have all the resources available for us. Now what was pending? Pending was P1, because it wanted 1750. At that time B was not having 7 instances, but now yes, we have 14 instances of B and 5 were required. Now we have 12 instances. That means this whole thing 1750 is less than what is currently available. Therefore now we can take up P1 0750, and that will allow the process P1 to have all the resources, and hence it will allow it to continue its execution, and once it is executed, then all the resources are made available and they are free now. So what has happened? So the sequence of execution, so first P0 is executed, then P2, then P3, then P4, and finally P1 gets executed. So 5 processes were there. P0 is done, P1 is done, P2 is done, P3 is done, and P4 is done. That means all 5 are done. Therefore there is no chance of any deadlock situation. Hence we can claim that this is a safe state. So the requested resources can be easily, comfortably, without any fear be allocated to these processes, and they are going to be executed in this sequence P0, P2, P3, P4 and finally P1. So that way all processes complete their job, and hence we see that there is no chance of deadlock, and hence can be allocated. So that is how this banker's algorithm will try to see whether the allocation of this is going to lead to safe state or not. If it leads to safe state, only then the resources are allocated, or otherwise it will just stop it. So that's all about this example. We have some more things to work on the banker's algorithm. So maybe we want to check any other example where which leads to an unsafe state and all that. So that's all about now. Thank you.